Welcome back to my channel, my first score EXE, and today I'm going to show you example 14 of proofs. So we have three statements right here. So we need to prove that first, x squared minus 8x plus 17 is always positive for all real numbers x. Now typically what I would do in this case is to complete the square. And to complete the square, you need to find the constant that will go here. And that will be the x coefficient, which will be 8, divided by 2, and then all squared. This will leave us with 16. And luckily enough, 17 could be split into 16 plus 1, where that 16 will belong to x squared minus 8x. So therefore we have x squared minus 8x plus 16 plus 1. This will be, we can express this in a square. We have x minus 4 squared plus 1. Notice that a perfect square is always greater than or equal to 0, and therefore this whole expression is greater than 0, and hence proven. For b, we need to show that this whole expression is equivalent to 5 minus 2x for all real numbers x. So this is just like an algebraic expression. Now normally I would just expand these two and I would just work things out. However, I would just try to factor this since these are technically differences of squares. So let's see what we have. So first we have x minus 3 plus x minus 2. And second, we will multiply that with x minus 3 minus x minus 2. Notice that I have written this in parentheses. And notice that this is equivalent to, let's say we have 2x minus 5. And then we have this x and this x will cancel. This 3x minus 2x, that will leave us with negative 1. So we can just leave a negative sign there. And after expanding this, we will get that this is equivalent to 5 minus 2x, as desired and hence proven. And finally for c, we need to show that n plus 2n plus 3n plus all the way up to xn is equivalent to n times x times in parentheses x plus 1, all divided by 2, for all natural numbers x and n. Now first thing to do is that we can factor an n out of this, so we're left with 1 plus 2 plus 3 plus all the way up to x. Now notice that this is a pretty famous sum, and its value is as n times x plus 1 over 2. And perhaps I will prove this. To show that our formula before holds, we can suppose that this sum here will be equal to s. Now let's suppose that same sum, but with its terms written backwards. So instead of 1 plus 2 plus all the way up to x, we're writing it backwards. So we have x plus x minus 1 plus x minus 2 and so on, all the way up to plus 1. Notice that we can add these together to get 2s on the left hand side, and we have this 2 added up will give us x plus 1. These two added up will give us yet another x plus 1, and we're adding it all the way up to yet another x plus 1. Notice here that we have x is x plus 1, since we have x's terms on the first original sum right here. So therefore we can write this into a multiplication expression. We have x times x plus 1. And to find the original sum itself, we can just divide both sides by 2. So hence, we have our sum is equivalent to x times x plus 1 over 2 as desired. Now back to the original problem, we have actually proven our statement here. So notice that I'll just perhaps write this a little like the original statement itself. So I have n times x plus 1 over 2 as desired. And this ends this video. Thank you for watching.